Okay, so this will be a walkthrough on how we are going to attempt the brute force attack on the VulnWeb application system. So in the terminal, we have the brute force Python script that takes several arguments. And in these arguments, we will need to specify the type, the format of the request, and the method of the request, and the field flag. So in order to find this, let's go to developer mode. Okay, so let's start by trying to find the arguments. So if just for example, let's type any username or password, lol, and hit sign in. Okay, so the first argument is the format of the request. So where can we find the format of the request? We can simply type on the request we made, and we go to the request field, and then we can hit that draw button, and we can see the format of the request that being sent in the payload. So this is the one of the arguments that we need to specify. The other one is the type of the request. The type of request, if we see here, we can find it, which is the method. Here the method is post, so the type of the request is post request. And the final argument is the fail flag. So here we want to specify an argument for the brute force script to tell him that if you have provided the wrong username and the wrong password, you will be able to know that they are invalid through this message, which says login failed. So when you see this message, that means the given username and the given password is not valid. So let's head back to the terminal and try to execute this command. So start by writing Python, because it's a Python script, and the name of the script Python brute force 1.py. Okay, now we need to specify the file of the username. This file contains all the possible usernames to brute force the system. The name of the file is test-username.txt, and then we need to specify the password file, which is a file that contains the possible passwords in order to brute force the system. The name of the file is test-password. Okay, now for the next argument, which is the format of the request in the payload. The flag is -d. The format is username equal characters. Here we specify the argument, the variable which will be replaced with the username in the username list, usr colon password equal. Here we will specify the variable that will be replaced with the possible passwords from the password list, pwr. Okay, so this is the format of the request. Now we need to specify the type of the request. The flag is -m. The type of the request as that we have seen is post request. And then for the fail flag, which will tell the script that when you see this flag, that means the given username and the given password are not correct. So let's copy it from the system, login failed, and we'll paste it here. Okay, now for the final argument is the URL of the system. We just simply copy it and paste it here, and we'll hit enter. Now it's going through all the possible username and passwords from the username text file and the password text file. So we'll just wait till it finds a possible match. No login match found. This demo code used for this training. It appears to be a problem here because it worked the last time. -F-M pwd. I think my argument is not correct. I think so. Yeah. I think the variable is pwd, not pwr. So let's try this again. Yeah, now it's working. Now it's actually replacing the variable pwd with the actual passwords. So this was a mistake. Now we just have to wait till we find a possible match. Okay, now we are done. As seen here, the script says login found, username guest, and password orange. That's good. Now let's try this one. Username is guest, and the password is orange. And let's hit sign in. And we are in. So this was the brute force attempt, and it worked. Okay, so now we have gotten into the web application system. We will try to move around, find any fields that we can abuse. So the customer's page is locked and the user's page is locked. I don't have authority. Probably I need to be an admin to be able to view this page. So there's one more page, and that is my profile. Okay, so here we can see a field that you can try cross-site scripting in it. XSS. There is settings and messages. Okay, so if we head to settings, let's try and execute a script. So this script basically escapes the cookies, which is a critical information that can be abused and used to bypass access control. So let's click on update and see if it will get executed. And it didn't execute. We can see that it got displayed here as the username of the user. So I came to conclusion that this field just basically like it takes a string, it doesn't parse it, it doesn't like compute it, it just simply takes a string and displays it. So any script that will be put here, it won't have any effect. It simply just will be treated just as a string that will just get displayed on the user profile. So since this didn't work, let's reset the page. And we are back to John Doe, the default. So now let's try to abuse this chat system where the user is talking to the admin. We'll paste the same script and hit send. And as you can see here, the script has been executed, and we can see the cookies critical information has been displayed, the authentication info, where we can use this later to see how we can bypass access control. Okay, so basically the type of this script is a stored script, which is stored in the web server, which is a dangerous one because now whenever the user John Doe logs in, the script will be executed, and also the administrator on his side, this part of the chat will be there. So when the administrator logs into the website system, that script will also be executed. And there are many of scripts that can be executed, like sending a malicious email, downloading a malicious file, escaping cookies, for example, escaping critical information about the system. So this is a huge vulnerability that is there in the system, and that's a walkthrough on how the cross-site script is being executed on the system. Now we will try to look into cookies for any critical information that we can find and try to exploit it, so that we hopefully will be able to elevate into an admin role. So to start, we'll go to the developer mode. We'll reload the last request. We will hit on any request. We'll go to the cookies, and there's an interesting field over here that's called authentication info, and it's using an encoded base64 value. So now our next task is to decode this value and know the original value that the web server system uses in order to authorize the user. So we'll go over here, we'll use the perform base64.py tool. So start by typing Python since it's a Python file, then the name of the tool, perform base64.py, and then we'll use the flag -d in order to decode the value. Now the value we want to decode is over here, so we'll just copy and paste it over here, and we'll hit enter. Now the displayed decoded value is 2 colon user. The 2 is the ID of the user, and user is the username of the user. So now we know that the system uses the ID and the username in order to authorize the user. So now this is a huge vulnerability because they're using a base64 in order to encode the critical information that it's easier for attackers to exploit. This is an OWASP top 10 vulnerability that's called sensitive data exposure. And in order to mitigate this vulnerability, the developer would be better if they use a strong encryption method, so that it will be extremely difficult for attackers to decrypt it. And now our next task is to see how we can modify this value and modify the value of the cookies in order to elevate it into an admin role. Let's try and perform an SQL injection to reveal all the users that are there in the system. So we go to developer mode by pressing F12. We can reload the last request. Headers, we can go to this URL that displays the list of the users, so we'll double click on it, and let's see, let's try and make an SQL injection here. So we'll make or 1 equal 1, 1 quotation on 1, and here we are, we have all the user listed. The ID number 1 is for the administrator user, and ID number 2 is for the guest user. Now before we try to elevate into an admin user, we first need to know what is the ID of this admin in order to modify the cookies values. So if you go to the request here, look into the header, we'll find that this request displays the user list, and there is an ID which is called 2, and we've came to conclusion that the ID number 2 is for the guest user, because when we decoded the value of the cookie, it was number 2. The number was 2. So now we need to know the ID of the admin. So in order to do this, we will go to the double click on the request, which will open in a new tab, and then we'll try to modify the URL. So let's try by typing 0. Look what it will list. So here it listed that ID number 1 is for the admin and ID number 2 is for the guest user. So here you can come to conclusion that when you have an ID number 1, this is for the administrator. So next we will try and encode a base64 value and then put it into the cookie, and hopefully we'll get into an admin role. So in order to start, we'll do the same thing, Python perform base64.py, and we don't want to decode, we just want to encode, so we'll just simply put the string we want to encode, which is the ID number 1 and the administrator. So we'll put 1 and then colon administrator, and then we'll hit enter. And there is the base64 encoded value that we'll use to modify the values in the cookies and hopefully be able to access the super admin web page. So we'll copy it. Now in order to do this, we will need to go to the storage over here, the storage field, and modify the cookie values. So we'll, in the authentication info, we'll paste our new encoded base64, and then we'll hit on the refresh button on the web browser, and here we are. Now we are a super user and administrator. So this is an OWASP top 10 vulnerability, which is a broken access control that we are able to access other users without proper authentication. And that's it. The next vulnerability that I have discovered is related to an OWASP top 10 vulnerability that's called insecure deserialization. What I mean by this is that the object that the cookies hold, the fields are not authorized correctly. Like, not all the fields are authorized. It only looks for a single field, which is the ID of the user. The type of the user is not an important matter for the web server, which is a problem because it's easier for the attacker to exploit this vulnerability. Like, all they need to do is just get the information about the ID of the user, and that's it. It doesn't matter what type of the user, what is the proper name of the type of the user. And furthermore, in a real life case or in real life websites and web systems, there is like many other fields in the objects, like not only the ID or the type of the user, but there's also tokens and sessions and other things. So if the web server only uses the ID alone to authorize the user, that's a huge vulnerability, because now the attacker, all he needs to is only know the ID of the user, and that's it. He doesn't need to exploit or modify the session. He doesn't need to exploit or modify the token. He doesn't need to exploit or modify the type of the user. All he needs to have is the ID. Okay, so let me demonstrate what I mean by this. So before, when we encoded the value of 1 colon administrator in order to modify the field of the cookie and elevate into an admin user, we typed the ID of the admin and the type of the user, which is administrator. What I'm saying here is that the web server system, it doesn't care about the type of the user. It only cares about the ID. Now this is a vulnerability that's called insecure deserialization. The object is not authorized correctly. Now let me demonstrate this vulnerability. So let's go over here, and the type of the user, I will type anything that doesn't make any sense. For example, Coco Lolo. Now this doesn't make any sense. There's no type of user that's called Coco Lolo. Now we'll hit enter. Now we'll have an encoded base64. So I will show you that it doesn't matter what type of user I have. If only I have the right ID, I will be able to still elevate into an admin user. So let me demonstrate this. First, let's reset our web page, refresh our web browser, and let's go to the cookies and paste our new encoded base64. Now this here, the ID is correct, but the type of the user doesn't make any sense. It's not correct. Okay, now let me refresh, and here I am, super user. I am a super user. I am an administrator, and it doesn't matter what type of user I am. I'll still be able to access and elevate into our super user. Now let's try cross-site scripting, but this time on the user web page side. Why this is important? Because sometimes, like each web page, sometimes the developer develop separate codes for each page. Like for example, one developer might secure some type of web page and it doesn't secure other type of web page. So what you are trying to do here is to see if the super user or the administrator web page, is it secure or is it the same as a normal user concerning the cross-site scripting. So now here's a script, and that we'll put in the chat between the administrator and the guest, and we'll send, and it got executed. So now we know that also the administrator or the super user web page is not secured when it comes to cross-site scripting. Now, of course, this is a vulnerability because if an attacker compromises a super user or like an administrator and he was able to inject a cross-site script, he from only the administrator, like here I can only talk to the guest, but in a real life scenario where I have a website or a web system that have like hundreds of users, I can just simply type a cross-site script and save it in the database, stored in the database, and I'll be able to send it to all the users, and all the users that logs into the system, the cross-site script will be executed. And of course we know what will happen after that. We can download malicious software, malicious files, send a phishing email, phishing website, everything is possible. So one more thing I would like to do is I would like to log in as a guest and see if this script has been executed on the guest side or not. So I'll sign out. I will log in as a guest, orange. Now I'll go to my profile and the script is executed. Why? Because the administrator has sent me a cross-site script, a cross-site XSS. Okay, so now that we have been elevated into an admin user, let's look out to other pages to see if there is any critical information that you can disclose. So in the dashboard there's nothing changed. Let's go to customers, and we have the list of customers over here. We have the first name, last name, and the username. So one last information that we want is the password of these customers. So we have their username, now we need their password. If you go to view, it will only just view the same information. We can't really post any information here because there's no button to send anything. So the only thing that we have available here to abuse is the URL, but you don't really know what to type or how to type it, like what URL or what query do they accept. So in order to figure this out, we can see view the page source. We go down to the scripts and see the URL that it accepts. So over here, takes the customers, and then if I type the ID and the actual ID of the customer, hopefully you will be able to view some critical information. So let's try this out. We'll try by typing ID and the ID of the customer, and here we go. Now this is an broken access control vulnerability in OWASP 10 because you are accessing unauthorized information disclosure by modifying the URL. So there is no actual access control that prevents me from accessing information I'm not supposed to access. So as you can see here, the field number 3 is the username, and field number 4 of the object, JSON object, is the actual password, which is hashed, that we can find a way later to unhash it and find the actual password to the customer. So the next thing we'll try is to do the SQL injection in the URL. So we know that in order to view the customers, we just have to type the ID, but we want to make a condition in the query so that it's always true and it views all the IDs of the customers and their username and passwords. So to achieve this, We know that it accepts the URL when we type customer/ID/1. Now let's modify the query to make it's always true so that it reveals everything. So we'll type or, no, wait, yeah, or 1 equals 1. Now this statement is always true, so it should reveal all the customers, and it worked. Now we have the list of all the customers and their username and their hash passwords using SQL injection. Now after we have the hashed passwords of the customers, next thing we want to do is to know the type of this hash. So over here we have a tool for this. It's called hash ID. It will return the type of this hash. So we'll type Python hash ID, and let's take the first hash and we paste it over here and hit enter. Now we can see the type of the hash is MD5. Now this is an OWASP built-in vulnerability that's called sensitive data exposure because it's using a weak type of hash to hash the passwords. A mitigation for this is to use a strong type of hashes and slow mode hashes like bcrypt and so on. Now since we know this is an MD5, let's decrypt this hash. So we have an online tool over here for MD5 decrypt. We'll paste the hash and decrypt. And yeah, so over here we can see the decrypted hash. So the password the user Poldo is using is QWERTY. We can do the same for everyone since the system uses the MD5 hash for every password, so all of them will be MD5 by default. The second one, it has the password. The third one, 1 2 3 4 5 6, some trivial passwords. And Dragon, the last one, let's see his password. Computer. Okay. Now let's take a look to the security configuration the system has by examining the requests. So if we go to the developer mode, developer tab, we reload the last requests. We can click on any one and then head to the security tab. If we skim through it, you can see that HTTP strict transport security is disabled. Now this is a vulnerability, it should be enabled. Another thing is public key pinning is disabled. This should be enabled because public key pinning protects against misissuance and certificate authority compromise and man-in-the-middle attack. So these are the two vulnerabilities that is found that is related to the OWASP top 10 security misconfiguration.